Okay, we're going to look at a particular type of sum of the geometric series, what is called a sum to infinity. We're looking what happens when the series converges, and for that to happen we need to have a ratio where mod of the ratio is less than 1. And what that means is that r to the n will approach 0 as n approaches infinity. No matter, even if it's 0.99 to the million, it tends towards 0. It gets smaller, smaller, smaller every time. And if that tends towards 0, all we're left with on the top is just a times 1, which is a. So we write, instead of Sn, we write S, short for sum to infinity, equals a over 1 minus r. And it has to be, specifically, mod r is less than 1. So it has to be this way around. R to the n tends towards 0, we're left with this formula here. So let's have a look at a couple of examples how it applies then. So here's our series 24 minus 16 plus 10 and 2/3 and so on. Why does it converge? Well, it converges because r equals minus 16 over 24, which is minus 2/3, and mod r equals 2/3, and that's less than 1. Even though the things go minus then plus, the overall sum will converge by oscillating. 24 minus 16 is 8, then add that to get 18 and 2/3, and so on and so forth. I'm guessing that the actual sum to infinity is going to be somewhere around 13ish, a rough guess. Let's have a look what it is then. So S equals, question mark, S equals a, 24, over 1 minus 2/3. Sorry, 1 minus 2/3. Panicking then, I wasn't going to get the right answer. So it's 24 over 5/3, or 3/5, times 24, which is going to be 7.2, 14.4. 13 was a guess, this is in the right sort of vicinity, so I'm there or thereabouts. As I say, it was a good idea. I was looking at that for r being 2/3 when r was actually minus 2/3. Always a good idea, therefore, to get your highlighters out. Highlight your A and highlight your R. Example 2, he wants the x values for when this one, where the terms are in terms of x, 1 plus 4x plus 16x squared and so on. When does it converge? Well, it's the r, in this case, is just 4x. Mod r has to be less than 1, so mod 4x is less than 1. We tend not to leave any constants in there. We do the opposite of constants, and in this case we divide by 4 to get mod x is less than a quarter. That's my sandwich range from minus a quarter to a quarter. Any x value in that range means that we're going to have a sum to infinity. And in this case, what does sum to infinity equal? A 1 over 1 minus 4x, and that's it in terms of x. The third example, it says that the sum to infinity is 5 times the first term. So I've shortened it as s equals 5a. So I can say that a over 1 minus r equals 5a. A's will cancel out and say 1 minus r is 1 over 5. So r is 4/5. Nice and straightforward. And we can use that to find other information now. And, I want to find the value of a. They can tell me that the fourth term is 38.4. That's ar cubed equals 38.4. A will equal 38.4 then, divided by 4/5 all cubed. Press buttons and see what we get. 38.4 divided by 0.8 shift cubed equals 75. So in that case there, that's my first term, that's my ratio, that's that one answered. And last one, interesting couple of questions. It's using this method. We've done this sort of question at GCSE, rewrite these recurring decimals as fractions. We're going to show how to use the sum to infinity to do this. So in this case, we're going to treat this as being 0.36 plus 0.36 times 1 over 100, and so on like that. So we're going to have a is 0.36, r equals 1 over 100, s equals a over 1 minus r is 0.36, 1 minus 100th is 0.99, times both by 100, 36 over 99, and obviously we can cancel down, we can divide them both by 9 to get a 4 over 11. check in the calculator you want to, work out and press 4 over 11, it should give you that as a decimal. 4b is almost the same. I need to split this up though as 0.2 because that's not recurring at all, plus 0.034. So as before then, when I look at this part of it, I can say that A is 0.034, R equals 1 over 100. So what does 0.234 recurring equal? It equals 0.2, a fifth because it wants it as a fraction, and then plus A, 0.034 over 1 minus R, 1 minus 100th, is 0.99. Get rid of the decimals, times everything by 1,000, 34 over 990, fifth, plus 17 over 495, common denominator 495, how many is into that one? 99, plus 17, which is 116 over 495. That's that. There's a check. 116 divided by 495 equals 0.233434, which is what we had at the start. Okay, so in that case there, we can use this sum to infinity method to work out the recurring part. There's a non-recurring part to add on as well. Add it all up, and there we are without a calculator, a different way of doing recurring decimals as fractions.